Welcome back to Wonder Maths, and today we are solving this probability problem. This is an extremely complicated problem. Most people couldn't think their way through this, and the reason that it's complicated is because it is conditional, and we will see when we get to that point why that matters so much. Most mathematicians would be reaching now for something called Bayes' theorem, but not us. We are going to solve this using simulation, which should be a lot more intuitive and a lot more understandable. And we are going to do it just very simply in a spreadsheet. I'm going to be using LibreOffice, but you could use Excel, exactly the same. And what we will do is that each row in our spreadsheet is going to represent one day. And each day there will be an 80% chance that we leave this laptop cable in the desk. And then the next morning we come in and search through the first 3 desk drawers. If we still haven't found it, and that's the conditional bit, what is the probability that it is in the 4th and final drawer? And I can tell you that the answer to this is apparently 0.5. It's 50%. So we will see if our spreadsheet simulation can get close to that estimate. So we're going to be estimating the probability. And here is our setup. We've got a column that represents whether or not we've left the cable. If we have left it, which drawer have we left it in? And then we will have these 4 columns, which will be a series of zeros and ones, 0 representing that it is not in that drawer, and a 1 representing that it is in that drawer. And we will do this using functions, and a function in a spreadsheet, in fact a function in all of computing, just is a block of code, a package of code that returns a value. And in our left column, the functions that we use will return whether or not we have left it with an 80% chance. So we will start equals if, that's our first function. If, open brackets, then we are going to create a wonky coin that when we toss it, 80% of the time it will come up yes, that we have left the laptop cable, and 20% of the time it will come up no. And to do that we will use another function called rand. And rand, open and close brackets with nothing in the brackets, will return a number between 0 and 1. And if a number between 0 and 1 is less than 0.8, that will happen 80% of the time. So that is our coin. We have just created a coin that when we toss it, 80% of the time it will come up yes. And that's the first thing we put after our first comma. And then another comma, the other side of the coin, will be no. Close your quotes. We need quotes because yes and no are text. Close your brackets at the end, press return, and we have just created our coin. Now, if we have left it, which drawer have we left it in? Well, for this we need another function. I'm going to be using rand between. Rand between 1 and 4. And that will create a random number, 1, 2, 3, or 4. And in this case, it's drawer number 1. Now, for this next cell, we're going to have the most complicated part of the whole thing. And we're going to be using a nested if statement. So in other words, we're going to have an if statement within an if statement. So let's go through this. We're going to go through it 4 times for each of the 4 drawers. So you've got 4 chances to see this. Equals if, open brackets. If this cell equals yes, that means that we have left it. Which drawer have we left it in? Well, it says here drawer 1, so we say if, so comma, and then if, open brackets, this cell equals 1, comma, then the cell that we are typing this nested if into will have the value 1. Otherwise, it will have the value 0. Close the brackets for the nested if, and then we need another comma and another 0, and that last 0 represents if the left column is no. Close brackets, press return, and it's changed to 2. We must have reset it, that's fine. Let's keep going. Equals if, open brackets, this cell equals yes, then if open brackets, this cell equals 2, then that's a 1, otherwise it's a 0 for the nested if, close brackets on the nested if, comma, 0 at the end, close brackets, press return. Yes, so it's refreshing every time we do something. It's giving us another random number. That's absolutely fine. Equals if on drawer 3, equals if, open brackets, this cell equals yes. If it does equal yes, then we've left it, so we need another if open brackets, this cell equals, we are on drawer 3, so if that cell equals 3, then we put a 1 in, otherwise we put a 0 in, close your brackets for the nested if, comma, 0 for the outer if, which means we haven't left it, close brackets, press return. And then our last go at this is equals if, open brackets, this cell equals yes. If it does, then we have a nested if to choose a drawer. If this cell equals, and this time we are on drawer 4, so we would put a 1 in there, otherwise a 0, close brackets, comma, 0 for the outer if, close brackets again, press return. And we have just created our first day. So let's go through this. Yes, we left it. We left it in drawer 1, so we've got a 1 there and a 0, 0, 0 there. And that's it. And let's go through this nested if statement just one last time so everybody gets it. If A2 equals yes, that means we've left the thing. Then we start another if. If B2 equals 4, which is because we're in drawer 4 here, if B2 equals 4, then we would have a 1 in this cell. That's the 1 there. Otherwise, we would have a 0 in that cell. And the 0 here represents if we haven't left it. And that's all there is to it. Now, that's one day simulated. To simulate other days, all we have to do is drag down. And you can simulate as many of these as you want. Let's simulate 110 because that's just where I landed. The more you simulate, the better your estimate is going to be. Now, I think the best thing to do at this stage is to copy paste our drawer data into a new spreadsheet. And we will paste special, and we will only take with us the numbers. We won't take with us the formulas. So I'm going to command copy that into a new spreadsheet. Paste special, I said. Paste unformatted text. Yes, that's exactly what we want. So now we have the numbers. We do not have the formula. And here comes the conditional bit, because we are only interested in the condition where we search through drawer 1, drawer 2 and drawer 3 and haven't found it. That's the condition. And this is why people struggle to think through these problems just in their heads. So what I'm going to do is I'm going to use autofilter to select just the zeros from each of these. I just want the zeros. And there it is. So there is my data. And then all I have to do is count the number of times I get a 1 here and count the number of times this condition comes up. So count the number of rows that I've got here. And that's me. I'm in business. I can calculate my estimation. So what I will do again is I will copy this into another new spreadsheet, because it just gets rid of the autofilter, which I don't want. Now, how to do this? Actually, what I can do, I think, is just sort it. Data sort, and I'm going to sort by drawer 4, and I want to sort it into descending, I think, so that I can count the number of ones really easily. So let's see, we have got 41 times the condition comes up because we don't count the first row. So we have got 41. Let's make a note of that. 41. and the number of times we find the thing is here, 22 times we find it. So our probability is going to be equals 22 divided by 41, 0.53. So we found it, we got it, 50% is a probability equals 50%. So we have estimated this probability without any formulas, without any Bayes theorem, without any complexities. And we've got a reasonable estimate. And if you wanted a more accurate estimate, all you would have to do is drag down your formulas from the first spreadsheet to maybe 500, maybe 1,000. You'd get a good estimate at 1,000. And that's it. Probability by simulation. Simple, powerful, and intuitive. I'll see you in another video.